We are live, I guess. Yeah, I'm live. Yes, I'm live. Let me open the chat window here. I see. Yeah, I'm able to interact with the chat. Let me edit few things. It's a 50. Finally, we are at 50. It's public categories education. Okay, that's it, I guess. Save. Yeah, we are good to go. It's AtCoder Weekly Contest 50. Let's see how much subscriber count we increase. No, 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 I'm not feeling sleepy. Come on, come on. It's a party. Come on, come on. It's a party. 1 minute to go. People will make fun. See, we should not distract. 1 minute to go. I have my PS code ready. Yes. Nice suggestion I'm getting. I should drink coffee and start a stream. That is something I will implement next time. 7, 5, 4, 3, 2, 1. Let's begin. Go to the task link. First question, second question. Takahashi has a sequence of n integers and Oki has an integer sequence of length p. Takahashi and Oki wants to make their two integer sequence match element by element. To achieve this, can perform this. Same index can increase AI, decrease AI, increase BI, or decrease PI. Minimum operation required to make this is equal. It's a easy question, right? So n, it's a C in n, vector A and B. C in A and B. Let's say answer 0. 0 less than n, I plus plus. I will add answer the absolute difference. That's it. See out answer. Yeah, let me submit and move to the next question. This should work. This should work. There's a Mac feature, right? It should give heart. I don't know why it's not produced. Let's move to the next question then. Takahashi managed an orchards. AI fruit growing on its tree. Okay. Starting from tomorrow, Takahashi will perform harvesting work over K days. Choose exactly one or orchard each day. He may choose the same orchard on the multiple day, and he is allowed to choose with zero fruit. Okay. An harvesting walk is performed at orchard I for 1 day. Takashi can harvest a number of fruit to equal to the smaller of the number of fruit currently remaining in the orchard and BI. In other words, if there are fruit remaining in the orchard, the harvest okay, and remaining number of fruit become R minus this. No new fruit grow, and the number of fruit in each orchard only decrease to harvesting. That's true. Can I get one subscriber today? Let's make it 140. Maximum number of fruit he can harvest. Maximum number of fruit he can harvest. Max Find the maximum. What we can do is what is R actually? In other word, R is the fruit, AI and BI. What's BI actually? R fruits remaining. Okay, so from this we can harvest BI. That's what, right? So always harvest fruit from a tree which has maximum number orchard which has maximum number of fruits. Hmm. In one operation, this is actually upper limit. At a time, you can harvest at most BI fruits from the tree. Okay, okay. Hmm. So we need something to related to priority key or what? Somehow we need to get to know which orchard has the maximum number of fruit currently. Hmm. Right. The first priority is number of fruit remaining on a orchard. Second priority is the maximum limit. Okay, and there's no third. There's only two priority, right? Hmm. Yeah, this way we can. Let me create a priority queue and k. Then Okay. So here we'll take our input, say A and B. A and B. A is the number of fruit and B is the maximum limit. So we want in this order only. Answer is equal to 0 for and Ti is equal to 0 is less than K I plus plus. Let's say auto. Hmm, let's say auto. Can we get 2x comma y and r comma b is equal to pq dot top? Yeah, it should work. Then pq dot pop. Cool. Answer plus is equal to minimum of r comma. Let me take first. Min is equal to minimum of r comma b. R minus is equal to minimum. Answer plus is equal to minimum. PQ dot push R comma B and see out answer. Yeah, pass, pass, failed, again failed. What the heck it is? Hmm. If R is 0, right? Then we don't add. Actually, I got it. We can harvest number of time also. If not, it is empty. Then also break. And if R, then only push. But here what I thought is first priority is not R actually. First priority is B. Or first priority is maximum number of fruit we get. That is actually, let's say, instead of this, what I thought is we can do like this. Hmm. This is what, right? While k is greater than 0, what I could to auto R comma P, like fruit F fruit comma P PQ dot top PQ dot pop. Okay. Do we have a chat? Wait. Didn't see. Okay. There's no one in the chat. Right. So int count is equal to F by P. K minus is equal to count. Okay. So here it is. If K is greater than equal to count, k minus is equal to count, and answer plus is equal to count. Answer plus is equal to f. Else what we are doing here is, yeah, answer plus is equal to uh, f by b into k. F by b into k and break. That's what I thought. Let's see how it goes. Still failing, right? Why? Why it's still failing? See, what exactly we did here is, in a one, like in operation, we get B fruit from any orchid. That is what it mentioned, right? In operation, we will get a BI fruit. Yeah, but total fruit can be. Wait. It's a simple question. See, don't let me. Don't make me complicated. We want a total number of fruits we can harvest, okay, in k days. So if we think greedily, we choose a orchard which has a maximum number of fruits, right? Then priority queue should work here, but the only thing is, see, priority queue should work here. So we should prioritize the number of, okay. Instead of this, let me do priority queue only. It should work here. Why? The question is, see, we get the A remaining fruit and B. Now, how many operation we can perform here? That is R by B, right? This many. If K is greater than equal to count, then K minus is equal to count and answer plus is equal to count into B, right? And what we will push now? We push here R minus count into B, comma P. See, we use this much fruit, so we left with this. We have R fruit. We use this many fruit, so we left with this many fruit. Right? We subtracted actually. That's all. Else, answer plus equal to count into not count into B. It's a K into B, and we'll break here. This should work actually. I don't know why it's not working. What's the priority? See, priority is to get maximum number of fruit. Okay. What I'm missing here? Is there anything I'm missing? Mm, Guys, if you're here, you can chat. Can, if I'm missing anything and you know what I'm missing, please let me know. Oh, you have to perform exactly. Okay. If Q dot empty, then break. Why I'm getting this? If R is equal to 0, still break. Cool. See, I passed this test case, but the thing is, what I'm missing, what I am missing here. Let me do some debug. I have 2 and 3, means there's 2 fruit left. Maximum I can bring 3, and there is 5 and 4. According to priority queue, this will on the top, right? Or see, if I am having what I'm thinking is something is bigger here, something is smaller here, something is smaller here, but this is what I'm thinking. No, no. We are doing. I'm doing correct, right? I don't know why. What I am missing. Can this be a binary such an answer? It can be, right? Let's do one thing. I will try the next question. I will come back to this question if Otherwise, just a time waste. Takashi love card game and plays card with the number written on them by stacking them on the deck. Each card has a positive integer written on it. Takashi built a pile by stacking card. When playing a new card, he put it on top of the pile, okay? And when remove card, he take okay. The removal card are discarded and not involved in any subsequent operation. Okay, initially a pile contain no card. Takashi perform an operation in order. Each operation is one of the following three types. Okay. Put, place a card with a positive indice written on the top of the pile. Remove the top notch card. Look, compute the bitwise XOR of the number written of all the cards. Okay. So these are the events. It can be put, remove, or look. If it is put, we will add one more card. If it is remove, we'll remove that card. And look, then we have to give XOR of. So it's like here they're asking, this seems easy to me. Let me explain why. If I understand question correctly, we'll get a new card, we'll maintain XOR, XOR, it's A. Once we get a new card, we'll do B. Once we get a new card, C. And once we get this look, then we simply output whatever the current XOR we are having. Okay. And see, if we want to remove, so you'll do again XOR, then remove this. XOR of same number becomes 0. So yeah, so we're currently maintaining the XOR in a correct fashion. Let me show you in a code, it will be easier. We have n events. Let's move to each, let's iterate through all the events. And it's a XOR. Current XOR is 0. Why? Let's say answer XOR. Okay. We'll firstly take the input type of event, scene type. If type is equal to put, then we include in our answer. Okay, type and the integer. Okay, if it is put, then we'll take input the card which we will going to put. Else if type is remove, then what we do is, oh, we want to maintain the stack also. st dot push x. Remove means we just do top is equal to, let's say temp is equal to st dot top answer XOR is equal to temp. That's it. And we pop that pop. Okay. Else, if it's a look event, sorry, then we simply our answer XOR we just print. I think we have -1 case also. In other words, number of most recent past looks operations that yield the same XOR with the ith look operation. What? If no such check this output minus one. See, we have an operation. Let Vi be the XOR value obtained by at ith look operation. Then we have to print minus one. Why we are getting hmm, this many minus one? Wait. 3, 5, and look. Why minus one here? Put 3, put 5, then look is equal. Then we have look. We have 3, we have 5, then we'll have something, right? Why minus one? Let Vi be the XOR value obtained at ith look operation and output the largest J such that J is less than I. If no say J such exists, something just what they are saying. What are they saying is we have to find the largest J which is smaller than I has this value. And we have to maintain the XOR also. Let's say what they just say. You have to find the largest J smaller than I has the same value. That's it, right? What we'll do here is instead of counting this, we'll find the largest J. If MP of count answer XOR is equal to 0, Cout minus 1. If SZ of MP of answer XOR equal to 1, Cout minus 1, else Cout MP of answer XOR dot R begin. R begin or what? Begin, right? Handle MP of answer XOR dot push or insert count plus plus. Why? What's happened? We debug MP of MP. MP is null, right? Continue. Minus one. Wow. Debug type. Put look. It's empty. Yeah. Put put. That's fine. What they're asking. Such that Vi is equal. What is Vi now? It's a value, right? Okay. And what's that actually? 6 and 6. This good. Good. And this is just happened. Why it's happening? It's always one. Hmm. Yeah, it's two. Hmm. Good. We are good to go. Let me submit and see. Let's submit. Let's submit. I'm still thinking about the second question. We are very close, actually. And we got AC on third. Let's move to D question and then we'll see. Can debug B? The car is strolling through a street, a city. The city has an intersection, and the intersection are connected by a bi-directional road. There are M road in total, and each road has a required travel time. Multiple road may connect the same pair of intersection, but there is no road connecting on the intersection to itself. No self-loop. Okay. A city has a K toll gates, each installed at a distinct intersection. The J toll gate is installed at intersection of LJ, and toll fees is CI. Okay. No toll fee is charged at intersection without a toll gate. Okay. Takashi want to travel from one to n. He want to move from intersections to intersection via road and okay, Takashi's route is this consecutive intersections. This must be directly connected by a road. A total cost of the trip is sum of following two components. It's a BFS. Discussed algorithm. Okay. Ha ha ha. What is W actually here? That number of toll gates separated by space. Oh, that's a travel time. Okay. Why we need a travel time actually? Find the minimum total cost only, right? Doesn't matter how long does the path take. Hi, Kapil. I'm in my master's last semester. Which year you are in? So the total cost of the cash. So see, we don't care about travel time, right? If I read a question correctly. I read a question correctly, right? So we don't care about travel time. We only care about this. What can I say? It's the intersection. So let me draw. We are here. Let's say these are the intersections. So if you want to move from here to here, you have to pay. If there is a toll here, you have to pay CI cost. You have to pay CI cost. Okay. Mm, what we can do is we can add this much weight to this node. If you travel from this, you have to pay this toll. Yeah, this is this is what we can do. And we simply perform what I can say, last algorithm. Yeah, that is what, right? Actually, we don't need a wait. Wait, am I missing anything or not? Let me first confirm before implementing. Nowhere they mentioned like you have to reach the minimum total cost. Takahashi is to travel from intersection 1 to intersection N. It is guaranteed that the intersection N is reachable from the intersection 1. Okay, okay. So I'm going to ignore this wait for now. Let me code it. And M and K. We have N nodes, M edges, and K tolls. Correct? That's all. Then we have this many edges. Let me take the input of edges. For now, what I'm thinking is Uh, See if there is a toll at Li is denoting. So at the jth toll gate is installed at intersection JI. K tolls. 1, 2, 3. How I know which GI it is? Let me draw this graph then. Let's say this is one node and this is second node. It's connected. And there is third node. It is also connected. 1, 2, 2, 3, and 3, 4. There is a fourth node which is also connected, and this is also connected. Okay. There is a toll at 3. This is what they're telling, right? Intersection Li. Third intersection. That is what there's. First, second, third. So we are having toll here. If we pass from here to here, we'll pay CI cost. If we pass here to here, we'll again pay CI cost. That's what they're telling, right? Yes, that is what. Yay, today we get one more subscriber. It's 140. Right. So I want to reach from 1 to n. I can go like this. It's a 10 here. Oh, okay. It's a 10. It's a 2. This is 2. This is 2 and this is 2, right? We can go like this and this. So, choosing, we have to output the minimum total cost. Cost is 0, right? Why 10? This is a confusing question. I don't want to try this. Let me debug my why what I'm missing in the B. That is good actually. We won't try in D. So here we are missing something. What's that? What is that? What is that? What I'm missing? It's a priority queue question, right? Because we are prioritizing the number of fruits and the highest number of fruits, that's the most priority, right? Only thing I'm confused is, are we maintaining the priority throughout the solution? See, this. I need to improve. I need to improve. Kapil Wentz. Yeah, Kapil is our new subscriber, I guess. Yeah, I never saw Kapil before. Should I try different approach? Uh, what's what's the simplest approach? See, let's not make it complicated. I have a knowledge. I know how many fruits I have on our yard, right? Yeah, but at a time, mm, okay, will perform K operation. Hitting zero means everything is zero. We are left. There is no fruit available anywhere. That's also fine. Then we saw like how many operation we can perform. This many. And we have performed this many operation and we'll get this many fruits. And the remaining fruits are this, right? I'm getting 16 here. Oh, what the fuck? Wait. It should be this. Why I'm getting one less? Let me debug. R, comma B. We're getting 10 and 4. And how many we used actually? How many we harvested from this 10 and 4? We harvested 8 because we can perform two operation. Yeah, that is fine. So we get 8 fruit from here, right? So if we follow the process, looks good. See, if you code the correct solution on the one go, there is no fun. If you debug and you will understand the process and then, so the destination doesn't matter. The joy you will get on the process that's matter. I heard from somewhere else. Currently we have this, and answer is 8, right? And we left, then we push back. Then we'll get this from here, we'll get 4 more. And here we perform 2 operation, right? Yeah, and we're done with the operations. I will get 13. 13 you won't get, right? Wait a minute. We may choose the same, okay, take it. And you can harvest minimum of R, BI fruits. That is what we did here. Why? In one operation, we'll get 4, then 4, 8. Oh, this is the better then. 3 and 5 is the better because in one operation we'll get 3, then it's become 13. Okay, now I got it. See, it's like perform 2 operation here, perform 1 operation here, and perform 1 operation here. Wow, this is good question. See how good it is. Hmm. How will handle this then? Hmm. K can be 10 to the power 18. So we have to use maths. We have to use maths, right? Otherwise we'll get a TLE. K is 10 to the power 18, then we have to use some maths. Otherwise this loop give us a TLE. Anyone knows like how we can approach? Let's see. Let me think till then. Hmm. Anyone? Can anyone? There's no one. Once I get a better audience, well, this time will be fun. What I'm missing is we are having our fruits, right? We are having our fruits and bees remaining. That is what question said, right? We want something like we want to get a maximum fruits. So somehow we need to manage, somehow we need to track, like what's the optimal way to get a maximum fruit. So I'm using binary. I'm using what I used is say what is priority queue. So it doesn't serve the purpose, right? It doesn't serve the purpose. The purpose is if you know the purpose is We want to take a maximum fruit, but see here, this is what the input 3 comma 4, uh, 10 comma 4, wait, 10 comma 4, 5 comma 2, and 3 comma 5. We'll perform two operation here, we'll get 8 fruit. We'll perform one operation here, we get a 2 fruit. And if we perform one operation here, we'll get a 3 fruit. That is what our desired answer is 13 fruit. Uh, I'm unable to come up with optimal solution. We'll see, like, we have still 2 minutes. We'll get to know, like, I want to know how we can solve this. It's a kind of interesting. Can we maintain something like fruits into, can we maintain the product of these two numbers? See, the 3 5s are 15, so to get this is more prioritized than this. Let me do that. Let me try quickly. Right, and here we'll maintain A comma B into B, and this is A, right? So this is our priority, and yeah, this is our priority, right? Then if R, that means let's say this is first and this is second. Let's remove this. If first dot second 0, then break. That's fine. Count is equal to first dot second comma second. Okay, then answer should be count into second. This should be first dot second. Wait. It's getting confusing, right? Wait. It's fine. But here we are pushing first into second into this. Into second. And this is second. Till we're getting the 10. Why this cola variety? Let me see some good solution. I told you I'm on the right track. Told you we just need to maintain the count and the remainder. Yeah, I got it. Uh, I fucked up the implementation. Otherwise, like decent. I came up with a decent solution. So that's all for today. Thanks for joining.